what we have here is a system. And we can solve this like it's a system of equations. And we have a couple methods for that, but our two favorite were elimination and substitution. And you see that with this system, we could solve it with elimination pretty easy if we change the signs at the numerator or denominator. But if we go through and multiply the numerator by a negative, do you see the y's cancel? And so we only have this 2x squared, but then we have a minus 3x. Y's cancel, and over here we have a 2.
Oh, so you don't.
So it's quadratic.
Alright, that's that.
So you don't, what do you call it? Add to it? Oh, never mind, just square.
Yeah, you get that?
This is different from the number 1 on your sheet though, right?
Yeah, it is.
Okay, good.
Then it gets 2x
It's supposed to be
plus
giving you
1.
4 different examples. Good. Alright,
Factor
so,
down to 2x
and look at here.
minus 2.
A great problem to practice factoring using trial and error.
Alright, did it.
If any of you still have an M on your grade book in Infinite Campus instead of a 20, that means it's missing. And an M averages in as a 0.
I heard my old and
Yeah.
grade.
It does. A little bit of both. So, but you have until,
Alright.
you know? Yeah, is that the last day?
Oh.
There we go. You have till that day. Yes, sir.
What does incomplete factor?
Huh?
What is an incomplete factor?
An incomplete?
Factorization.
0. No, not for that, but just in general.
In the grade book? An incomplete? It doesn't average in at all
It didn't change your grade.
until at the end of the semester. If it's still incomplete, a lot of times it goes in as a 0.
Oh, jeez. Why would you want it to?
But because that means you never completed it. Yeah. And if you never complete it,
In my mind, you got like a little credit to live in from that 0.
well, sometimes I do that. Like if a worksheet's 10 points,
I give you 3 or 4.
yeah. But most of the time we go over everything in here, so that's why I can't take late work because I can't really give credit for copying.
That's really.
Yeah, copying's easy.
I don't know.
All right, so 2x and x and 2 and 1 and negative and positive. Is that how you do it? Or something like that? Yeah. Okay, so either x equals negative 1/2 or x equals 2.
I just
2.
Okay, now when we do these, we're going to plug them back into our equation of least degree. So right here I've got a quadratic and I go to linear. It'll get plugged into the linear. That's correct. So I like to think of it like this: y over here, 2 over there. Y'all good with that? So when I plug it in, it's a little easier for me to see. So I get negative 1/2 times 3, which is negative 3/2, or negative 1.5, and negative 1.5 plus 2 is a positive 0.5. Okay, then I can plug in 2. 3 times 2 is 6, plus 2 is 8. Okay? So, that means if I graph this, these two graphs would intersect how many times? Twice! 2 points of intersection. And we're going to look at our graphing calculators with example 4. You can go ahead and get it if you want, sure. Okay, any questions on example 1?
Scared the crap out of me.
That's right.
Share a calculator.
Alright, number 4 you said?
What color was your calculator?
Just black. Your generic graphing calculator.
Just plain black with no name.
Your
Just for
generic
fun.
as possible.
Just for fun, generic black, no name.
Yeah. Pretty much.
Alright. Okay. So we're going to use the calculators, but we're going to hold off on those for a minute. Now, we're going to continue to focus on algebraically. Now, if this looks familiar to you, it should, because we did this in the polynomial unit. Do you guys remember that? Unit 5, when we got back from the semester break. So this kind of stuff will be on your exam. So it's kind of cool that we're seeing it again. So, we have a linear and a cubic this time. Now, which algebraic form of solving to find the intersection would you like to use?
Substitution.
Substitution. So we'll plug in the negative 2x where the y was in the top equation. We'll set it equal to 0. So when we move that 2x over, this becomes a minus x. We get excited because we see a GCF.
X.
X. Excellent.
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 Huh? Am I the one that didn't catch that? Didn't catch that. No one threw it at me, so I didn't catch it.
Alright, and now the binomial factors further. What's the binomial factor to? X plus 1? X minus 1.
Which is a, if you
So now, what could X be here?
0.
0. Here.
-1.
And finally here.
1.
Alright. So we have 3 possible solutions. We're going to plug it in to the equation of lesser degree, which is the linear. So we plug in the 0. 0 times anything is still
0.
0. We plug in the negative 1. Negative 1 times negative 2 is
2.
2. And we plug in the 1. 1 times negative 2 is negative 2.
A.
Yes.
Can we do an example with like the square root?
Yes.
I think I was like,
Wow.
I said next when we see the future. It's a thing that happens.
That was pretty cool.
Are you the male version or
Ah.
No, no. I don't think you guys know what that is.
Okay. Number 3. Alright, number 3. Let's write down
Physically
example
painful.
3.
Oh.
You never know. Really, you never know.
Merry Chrysler.
Happy nap.
Merry Christ.
Merry Christmas. Christmas.
Happy criminal.
Merry Chrysler.
Okay. Number 3.
Merry Chrysler.
I never said that.
Just want to remind you, we are recording.
What's up, all you YouTubers out there?
How's it
Welcome to
going?
Woodlands Math.
Merry Christmas.
We do lots of math.
Merry
Yeah.
Chrysler.
All right. Okay, so substitution or elimination, folks. Which way?
Elimination.
I did substitution.
Substitution. They're
Because you
both
have y
compromises.
equals,
That's
so you
right.
can just do equals equals.
Yes. So we'll plug that in where the y was. All right. Who has ideas? What do we do?
I did not know.
Square. I like it.
Side.
Okay, so why don't we square this side, and why don't we square this side? Okay, so the nice thing about this side is the square and the square root cancel, and we're left with x plus 3.
On that side, I
And then you
got
get negative 4x.
negative 2x squared.
Okay, negative square the first, so negative 2x squared is positive 4x squared.
Oh, I'm stupid.
And then we double the product. The product is negative 8x, so we double it, negative 16x. And then we square the last.
We said double.
Square the first, double the product, square the last. Hit.
I just missed out on that.
No, we did this like in the beginning or in the
I was
last
like
semester.
writing.
So you square the first equation, you add
Oh, gotcha.
get
Never
the
mind.
product.
Yeah, I
Times
got you
two is
now.
negative 16, double that.
Yeah, I got it now.
Okay, and now it's a quadratic. So what does it have to equal? 0. So I'm going to take this little bit and move it over there with all that. And so when I subtract an x, now I have negative 17 x's. And when I subtract 3, I have positive 13. Eight factors. Let's see if you can do it. How? I bet you can figure it out.
I got it.
Sam, no one asked you.
I asked. Yeah, you want me to eat all that? Mid-bowl.
I had hit it. I know it's like an
Oh, this thing so high.
call.
It's not going as far as
He goes, no.
Oh, man, we're up here.
You silly goose.
Dang it.
It'd be so much easier that 13 was a 15 because I would have solved it.
Alright, so I'm going to do, I know that 13 and 4 will make 17. I just can't have them together. Right? So I can't put the 13 right there because that would be 13 times 4. And I need the 13 to be plus the 4. So if I do that, I got negative 4 and negative 13 is negative 17. Hurrah! Okay? So x equals 13 fourths. Or x equals 1.
Plug
Okay.
it back in.
Now when we're plugging it in to the equation of lesser degree, when we're looking at the exponent, this is not polynomial, so we really wouldn't find the degree of it. But this is 1, and this is like to the 1/2 power. So we're gonna plug it into the square root. Because the square root is our limiting function. Because we can't have a square root of a negative on a graph, right?
But this one.
Well, the cool thing is when we plug in both of these, they both work. But sometimes only one of them will work. So make sure you plug it in to the function that has the lesser degree. So in this case, we're plugging it in here. And so when we do 13 fourths plus 3, 3 would be 12 fourths, right?
I'm so bad at that.
3 is the same as 12 fourths.
It is.
Okay? 3 is the same as 12 fourths. Alright, so this is 25 fourths. And the square root of 25 is 5. The square root of 4 is 2. So one solution is 13 fourths, comma, 5 halves.
I'll get it by the end. I'm bad with
That's
Keep it
fast
stars.
approaching.
I'm really
Yeah,
bad.
test
I'm
and,
so
like-
bad with fractions.
Well, use your calculator.
But sometimes there's no calculator parts on fractions. Like fractions.
Well, that's true. Sometimes I do have no calculator parts.
He's actually really bad at them.
I'm over here
That's
like,
what
I
he's
don't
like.
know how
I
to
always
do it.
convert them over to decimals and that didn't like
Yeah, that's what he has to
then
do.
like the fraction button to make them go back to the fraction.
Huh.
He said if he doesn't have a calculator, he's done. Yeah, he's done at geometry.
I'm like, Mom, can you come pick me up?
I mean, if you have 1/3 and 1 divided by 3, you can just have 1 divided by 3 and then just keep it all together and then just save it round. And then you just save it yeah. Your calculator and you like that.
Yeah, that'd be wrong.
No, I divide it and then I just calculate it. I just save it around.
Alright. So, here we go. 13 fourths, 5 halves. And 1, 2. Alright, guys, enter this under Y1. Enter this under Y2. And let's see. Does it intersect twice? I was, but I jumped the gun because this one looks exciting. Jump the gun.
And then she's like,
Gentlemen, you're trying this on your calculator.
Oh, no. Plug it in.
This process
you got it.
You usually struggle with mine already hit it at one point.
Oh, well,
Yeah,
mine hit it
doesn't hit
too,
twice.
so I did it right. Hey, Meg, I really don't think I have
I need to know what
Mine
they
all
are.
has supposed to be
We need
at
to break
one
it.
like the aroma surrounding.
What if we zoom out with the line?
No.
It's a lot easier.
Go ahead, Connor.
Okay.
See what I'm trying to help us with it? He gets aggressive.
I literally just got
Ooh, they cross. They cross it this month.
Yeah, but they only cross They only cross once.
It does appear they only cross once.
Wait, mine crossed twice.
No, it doesn't.
It did.
Hers has a.
Hers is a downward parabola.
Why is it a parabola?
There's no X. What'd you put in?
Oh wait, did I put it? Oh, I just put it X squared.
X squared goes 4.
She's like, I got this one.
There, I fixed it. Thank you.
Now it doesn't cross it twice.
No, it doesn't cross at all. No, it crosses. My graph's right.
Hey, Tommy, you have a graph? She all graph because you know why? You know why?
Hey, do you have any lead?
Yes.
Is it because when you plug in the third report into the second one, it's like a negative? She's gonna staple it. Like you get negative.
Oh, it is exactly why. Okay, so if we plug the 13/4 in here, we get a different answer. We don't get positive 5/2. We get negative 5/2. So that 13/4. Extraneous solution. That was terrible. Okay, so that 13/4 gave us an answer that doesn't work. It's got to work for both equations, and we plug it into the top one and we get 5/2, but we plug it into the bottom one and we get negative.
So do you have to plug it into both and not just lesser degree? Okay.
Oh no.
Normally, the one of lesser degree won't lead you wrong, but this time it did.
Okay.
Yep. Positive for one, negative for the other, doesn't work. So we only have one intersection on that one. Yep. And we can verify graphically. Okay, now, the last one. We're going to kind of do the same thing with. We're going to see algebraically what we get. And then we can verify graphically if all of our answers will work. They're not all going to work.
Good.
Yeah.
It's not actually.
All right, so we're going to use substitution again. That just makes sense. So we get negative 2x squared equals 3 absolute value of x minus 5. 3 times the absolute value of x minus 5. Now, when we solved absolute value equations earlier in this unit, we always isolated the absolute value. You want to take that approach, or you
No,
want to throw
of course
something?
not. Do something different. Couldn't fit.
I think
Yourself.
Alright. I would suggest taking that approach. Okay, so we move the 5 over and it becomes positive. Divide by the 3.
You're not gonna do it for
Alright, so this stuff can either equal positive or negative x, can't it? Okay, so that's what we do right here. We'd split it into the two possibilities. This stuff can either equal positive x, or this stuff might also be able to equal negative x. Maybe. We're going to have to test at the end to see what works. So, easiest thing to do is multiply by 3. And then it's a quadratic, so we set it equal to 0. I'm moving the squared over because I really like for my squared term to be positive. It's much easier for me to factor when it's positive. And I know that 5 take away 2 is 3. So let's do a 2x here and an x here. And I need a positive 5 and a negative 2. There we go.
That's a 1.
Right, but a positive 5x and a negative 2x. So I got possibilities of negative 5/2 and positive 1 right there. Yes, sir.
What is that? Oh, wait, never mind.
Okay, so if these are 2 of my choices, shouldn't the opposites of those also be choices? Yeah? So I think I know what's going to happen, but let's just prove it. Oh, look at there. I proved it. This factors 2, a 2, and a 1. And I need a negative 5 and a positive 1. So I get positive 5/2 or negative 1. Did I get the opposite?
Yes.
Yeah, I knew it. I knew it right there, didn't I? Okay, so we have 4 possibilities. x equals positive or negative 1 or positive or negative 5 halves. But we know that's not possible because an absolute value looks like this and a quadratic looks like this. And is it possible for those two functions to intersect 4 times? No. We could get 1, we could get 2, and that's it. It's either 0, 1, or 2. So we know all 4 don't work. Okay? So if I plug in positive 1, I get 3 minus 5 is negative 2. If I plug it in positive 1, I get out negative 2. Okay, so this one works because it works for both, right? All right, let's plug in negative 1. If I plug in negative 1, I get 3 minus 5 is negative 2. If I plug in negative 1, negative 1 squared is 1 times negative. Okay, this one works and this one works. So what does that tell me about the next two?
They don't.
They don't. And they don't. If you plug in 5 halves, here you get 15 halves, which is positive. 7.5 minus 5 is positive. And when I plug it in here, it has to be negative. And that's going to happen both times. So these are the two that work. Now, let's verify using your graphing calculator. So if you guys will pull out those graphing calculators one more time.
Graph.
Let's do those two.
Break it.
That's why I wanted to do that with you, to remind us where the absolute value is again. Okay?
I swear to God, you do that.
Alright, so our equation is 3 times the absolute value. So what we're going to hit is the math button, arrow over to number, and absolute value is choice 1. So math, arrow over number, choice 1. Okay, so that, 3x, and then it was minus 5. And then my second equation was negative 2x squared. And then if I look at the graph, there's my pretty blue absolute value function. And here comes my red function. And does this look like negative 1, negative 2, positive 1, negative 2? It does. And I actually can see that on my table here. Negative 1. Okay, for the second function, did you use the negative button instead of the minus? Got to make sure you use the negative, which is located right down here beside the decimal point.
Yeah, they're both negative. They're actually both subtraction.
Okay, on the second one, you can't use the subtraction, you have to use the negative button.
Okay.
Okay, so we should be able to see right here one solution, and right here the other solution. And we can also see they don't cross anywhere else. Alright, so the worksheet that you picked up as you came in. The front is algebraic. The back is calculator. So if you're having fun with your calculator, knock out the back real quick. If you want to practice some algebraic, start it first.
I like this whole function. Working class.
I know, we've had a lot of that, haven't we?
A lot.